and welcome. I'm Dr. Abnita and I'm reading the USMLE First Aid textbook for Step 1, and this is page 332. We are starting the physiology section of endocrine. This is pretty long because there are 9 pages to this, so we'll do it in parts. So starting on page 1, this is page 332 by the way, and I'm using the 2024 version of the First Aid. Now, hypothalamic pituitary hormone. So this is divided into multiple hormones. We talked about this in the earlier video. Now, ADH, antidiuretic hormone, and the oxytocin is the two we know comes from the posterior pituitary gland. And then, so antidiuretic hormone, this is the one that increases water permeability of the distal convoluted tubule and the collecting duct cells in the kidney, and increases water reabsorption because it is antidiuretic. And alcohol consumption can decrease the antidiuretic hormone and cause increase in the urination, so it causes polyuria and dehydration. So antidiuretic hormone increase permeability to water at the level of the kidney. So this is the collecting duct and this is the distal convoluted tubule. So these are the two places where the water permeability increases by the help of ADH, and then there is increased reabsorption of water. But alcohol intake will decrease the effect of ADH, and this can cause polyuria and dehydration. Then corticotropin releasing hormone, which is CRH. So CRH will increase the level of ACTH, and it will also increase the level of the MSH and beta endorphins. So if you remember correctly, that the hold on, let's go back to this page. Here you go. So the pro-opiomelanocortin derivatives is beta endorphins, ACTH, and MSH. Right here in this corner it's written here. So go pro with the BAM. So these three will increase by itself, like these three will increase together. So the corticotropin releasing hormone, it stimulates main corticotropin releasing hormone. Obviously it's working for the ACTH, but because these are the other two are derived from the same cell, so that means the other two will increase as well. So MSH and beta endorphins. That's why you'll see in Cushing disease that the patients will have this the hyperpigmentation because of this MSH, because it causes the melanogenesis by melanocytes. So in corticotropin releasing hormone, the ACTH increases, MSH increases, and beta endorphins increases. So what happens is the CRH will decrease in chronic glucocorticoid use. So chronic glucocorticoid use will decrease in the CRH, and CRH is so corticotropin releasing hormone, obviously ACTH, but we want to remember the GoPro with the BAM mnemonic. So whatever that is, pro-opiomelanocortin. Yes, pro-opiomelanocortin is where the BAM is derived from. So beta endorphins, A for ACTH and M for MSH. Then dopamine is related to decrease in prolactin and TSH. So decrease in prolactin and TSH. So that means dopamine, if you block dopamine, there will be increase in prolactin and TSH. So these dopamine is called, the dopamine itself is called the prolactin inhibiting factor. The dopamine antagonist, example antipsychotics, can cause galactorrhea due to hyperprolactinemia. That makes sense, because if you're blocking the dopamine, the prolactin level will go up, and that can cause galactorrhea. Then GHRH, growth hormone releasing hormone, obviously increases the growth hormone. So the analog of growth hormone releasing hormone is called tesamorelin, and it is used to treat HIV associated lipodystrophy. Then GnRH and the gonadotropin releasing hormone, and this increases FSH and LH. So GnRH, it is affected if there is too much of prolactin as well. So hyperprolactinemia can decrease or suppress GnRH, and the tonic GnRH analog called leuprolide, it suppresses hypothalamic pituitary gonadal axis, and the pulsatile GnRH is needed for puberty and fertility. So GnRH, gonadotropin releasing hormone, increases FSH, LH. Too much prolactin causes suppression of GnRH, and GnRH derivative is called the leuprolide, that suppresses the hypothalamic pituitary gonadal axis, and pulsatile GnRH is needed for puberty and fertility. Then MSH, this is the one that we're talking about, the GoPro with BAM. So melanogenesis by melanocyte. MSH causes melanogenesis by melanocyte, and it can cause hyperpigmentation in Cushing disease, as MSH and ACTH share the same precursor molecule, which is the pro-opiomelanocortin. So, and also I believe that beta endorphin also increases with this. Then oxytocin, this causes uterine contraction during labor, responsible for milk let down reflex in response to suckling. Oxytocin, it can also modulate fever, anxiety, social bonding, mood, and depression. So oxytocin, two things, it contracts the uterus and helps in milk letdown, and actually more than two things, because it basically builds a lot of our personalities like fear, anxiety, social bonding, mood, and it can cause depression as well, and it modulates depression. Then prolactin. So prolactin in itself, we talked about this, that prolactin can increase or decrease depending on what hormone we're talking about. Dopamine, we're talking about dopamine up here. So dopamine decreases prolactin. That means if you block dopamine, there will be increasing prolactin. Then we're talking about GnRH, and we mentioned prolactin. That means that increase in prolactin level will suppress GnRH level. That means high GnRH will suppress the prolactin level. And then we talked about now we're talking about prolactin itself. It decreases GnRH, we just talked about that, and it stimulates lactogenesis. And so pituitary prolactinoma, that means a mass that is basically producing prolactin, and so high amount of prolactin, it will suppress things, it will suppress GnRH. And also we were just talking about this part where the dopamine, so dopamine decreases prolactin level. That means that you would want something dopamine related for a prolactinoma, and but we'll come to that when we talk about the pathologies. But for now, for pituitary prolactinoma, because GnRH decreases, it can cause amenorrhea, and because FSH-LH is not there, estrogen progesterone will be out of going crazy. So amenorrhea, osteoporosis, hypogonadism, and galactorrhea is common. And then breastfeeding moms, they'll have increased amount of prolactin. GnRH would be low. This can cause delayed postpartum ovulation, and therefore is known as natural contraception. Then somatostatin, I feel like statin sounds like stopping or something, but yeah, it decreases the growth hormone and TSH, and it is also called growth hormone inhibiting hormone. So somatostatin actually stops growth hormone and TSH. Then thyroid releasing hormone, TRH is responsible for increasing the TSH and increasing prolactin. So TRH, if in the case where there is increase in TRH, such as in primary or secondary hypothyroidism, that means that the T3 T4 would be low. It will send in signal to release more of TSH to stimulate more T3 T4, and therefore TRH will increase, and TRH is responsible for increasing TSH and prolactin. And so TRH increase in primary or secondary hypothyroidism can lead to increase in the prolactin secretion, leading to galactorrhea. Then there is a little picture at the bottom here, and it is talking about the hypothalamus and the hormones that releases, and then the response of anterior pituitary to these hormones. And then so we'll talk about these two, and these are divided into basophils and acidophils. So I remember the acidophils are the acid pigs and PIG. So the P is for prolactin and G is for growth hormone, and then the rest of them are basophils. So the hypothalamus itself releases corticotropin releasing hormone, and that releases ACTH. And then the gonadotropin releasing hormone releases FSH and LH. The gonadotropin releasing hormone, there's a negative sign on top of it, and we know that would be because of high prolactin. And then there is TRH, that is thyroid releasing hormone, releases TSH. TSH has two negatives on top of it, so one of them we know is somatostatin, decreases growth hormone, and it decreases the thyroid stimulating hormone. The second stop is from the prolactin levels, the DA levels, that releases prolactin. And then My bad. I meant DA, which is dopamine. It blocks prolactin and TSH. So dopamine in itself, it will block the level of prolactin and TSH. So we will just go back to dopamine right here, and we know that the dopamine decreases prolactin and TSH. And so dopamine decreases prolactin, TSH. Prolactin itself will stimulate the release of the thyroid releasing hormone, and it also increase in the thyroid releasing hormone increases in TSH, and somatostatin blocks thyroid releasing hormone and growth hormone is released by the stimulation of growth hormone releasing hormone. So the one hormone that stops other two hormones is somatostatin stops TSH and growth hormone. Prolactin also stops couple of things. The main thing is the GnRH, where you end up having that anovulatory cycles, and also there would be this the prolactinoma that can lead to amenorrhea, osteoporosis, hypogonadism, and galactorrhea. So that's prolactin sections. And then dopamine can block the prolactin release and TSH release. And yeah, I think that's pretty much it for the first page. Thanks for listening, and bye.